So we have 5.5 part 2, solving rational equations, and we're just going to look at solving simple rational equations here that are not proportions. So still our goal is to solve rational equations and be able to check for extraneous solutions and understand why we have extraneous solutions. So here would be a rational equation that we're looking at solving today. Looks super crazy, it's not too bad. Especially this one here. So it says solve and check for extraneous solutions. Well, we have a fraction minus a fraction equal to another fraction. So remember, when we are subtracting or adding, we need common denominators. So here we also need common denominators. That's why we did that whole lesson. Luckily, in this equation here, what do we have? Common denominators. So this is going to be very similar to one that we did in part 1 with proportions. When you have a common denominator already, you're just looking for what's going to make the numerator work. We're going to solve for the numerator because if we plug in any x value in the denominator, it's going to make it the same because they're all the same. The only thing we have to pay attention for is extraneous solutions. So remember, extraneous solutions is an apparent solution from the solving process that doesn't actually satisfy the equation. And what doesn't satisfy a rational equation? The denominator being 0. So we can always start by finding our domain restriction, and then if we have an x value that is that, we know it's an extraneous solution. So we already have common denominators here. So our domain restriction would be that x cannot be 2, because that's going to make my denominator 0, any of them. So this is what would create an extraneous solution that we need to check for. Now, since we said the denominators are all the same, when we add them up or subtract them, it's the exact same thing. Any x value is going to make them all equal because they're all the same. So we can kind of ignore the denominator and just go ahead and solve the numerator. So if I write that down, I have 8 minus 5x equals 12. So now I just have to solve this, and that is my solution, my x value. So I have a positive 8, so I need to move that to the other side. So I'm going to subtract 8. And that's going to give me negative 5x equals 12 minus 8, which is going to give me 4. And then divide by negative 5. X equals negative 4/5. So this would be my solution. Check to make sure that it's not an extraneous solution. Well, it's not positive 2, so it's not going to be an extraneous solution. So if you take this and you plug it in, you should see that it's going to make this a true statement. You can always check that on your test just to make sure that you do have the correct answer, because it should equal on both sides when you plug it in. So example number 1 was super nice because we had common denominators. Unfortunately, a lot of the times we're not going to have common denominators. So what do we have to do? Create that. So here's example 2. We have x squared over 8 minus 4 equals x over 2. Well, the easiest thing to do is have all fractions so we can get all common denominators. Remember, if we have a whole number, we can always write it over 1. All right, so now we have 3 fractions. All 3 fractions have to have a common denominator. So we have 8, 1, and 2. Well, nice thing here is I'm not going to have any domain restrictions because I don't have any x values in the denominator, and none of those numbers are 0. So now I just need to get common denominators. So 8 is my largest number, so I want to see, can I make the other ones become 8? And yes, I can. I can multiply 2 by 4 to give me 8, and 1 by 8 to give me 8. And remember, I have to always multiply the numerator and the denominator. So the first one I don't have to do anything to. The second one I have to multiply the denominator and the numerator by 8. And then to get this to be 8, I only have to multiply by 4. So let me go ahead and multiply those together and rewrite it out. So I have x squared over 8 minus 32 over 8 equals 4x over 8. So now my denominator is common at an 8. So now, obviously, that's going to stay equal. So I just need to solve the numerator. So I have x squared minus 32 equal to 4x. When I have something that's x squared, I need to get everything on that side so then I can factor. So I want to subtract 4x. That's not going to combine with anything. So it's just going to become x squared minus 4x minus 32 is equal to 0. So now that it's set equal to 0, I can factor. And I'm adding to negative 4, multiplying to 32. So I've got 1 and 32, 2 and 16, 4 and 8. So I'm going to use 8 and 4. And since 4 is negative, 8 is going to be negative, the bigger number. So I have x minus 8 and x plus 4. So my two solutions then are going to be x equals 8 and x equals negative 4. Neither one of these make the denominator 0, so they are both going to be my solutions. So since I have x squared, I can have two solutions, one solution or no solution. In this instance, I have 2. And when I plug this in, I should see that it does, in fact, make both sides equal. And I can always plug it in to verify that they are the correct solutions, but I just need to use that denominator and the domain restriction to determine if it's extraneous or not. Example 3, same concept here, solve and check. So in my denominator, looking at my domain restrictions, x cannot be 0. 0 is going to make it 0 in the denominator because I have a single x. So I got to keep that in mind when I get my answers to check for extraneous. Now, 4, x, and 2. None of those are the same. So I need to create a common denominator. And I can make 2 into 4. I can multiply the x by a 4. So my number that's going to be common is 4, but they also have to have an x because the second fraction has an x. So my common denominator is going to be 4x. So that's what I want to make each of my denominators. So I have to think about what do I have to multiply each one by to get a denominator of 4x. So here I have 4, so I just have to multiply by x, numerator and denominator. Here I have an x, so I need to multiply by 4. And here I have a 2, so to get that to be 4x, I need to multiply by 2x. So let's go ahead and multiply. X times x is x squared over 4x minus 2 times 4 is 8 over 4x. And that's going to be equal to 1 times 2x, which is 2x over 4x. So since those are all common, they're going to be equal. So I need to solve my numerator. And I have x squared minus 8 equals 2x. Get everything on the side with x squared, so I'm going to subtract over 2x. It doesn't combine, so I'm left with x squared minus 2x minus 8 equals 0. So now I can factor. So what adds to negative 2 but multiplies to negative 8? I only got two options, 1 and 8. That's not going to work. And 4 and 2. So I'm going to have 4 and 2. Since I'm adding to a negative, I need my larger number to be negative, smaller to be positive. So that gives me two solutions once again. And my solutions are going to be x equals 4 and x equals negative 2. Now, those aren't going to make the denominator 0. They're not one of my domain restrictions. So once again, they both work. Both of these are my solutions because they are not one of the restrictions for my domain. And if I plug in 4 and -2, it would make it equal. And I can always do that to check to make sure I'm correct. So we've got 3 more examples left, and the 2 after this get a little bit more complicated. But for this one, this is similar to the ones that we just did, so I'd like you to give this a try. Pause the video, try it out, hit play, and then you can check your answer. All right, so the first thing was, what was my domain restriction? And x could not be 2. So as long as you don't get 2, you don't have any extraneous solutions. So in this case, the first 2 fractions had the same denominator. The third one was over 1. So I had to multiply that fraction by x minus 2 to get a common denominator. And then I multiplied that out here. And then I said, okay, my denominator is the same, so I'm going to solve my numerator. And when I solved my numerator, I got -3/4. That's not 2, so it's not an extraneous solution, and it is, in fact, the actual solution to this rational equation. So that is my answer. And here's the big guy. So example number 5, solve and check for extraneous solutions. So we have x over x minus 3, 2x over x plus 3, and 18 over x squared minus 9. None of those right now are the same. So just like we did before, what I said during adding and subtracting was if you had anything that could factor in the denominator, factor it, because that's going to see if we have anything in common that we can work with. So I can factor this, so I'm going to replace this with what it factors to, which is x plus 3, x minus 3. So now my denominator for my third fraction is x plus 3, x minus 3. Well, now I can see I do have some things in common. The first one has an x minus 3, so it needs an x plus 3. The second one has an x plus 3, so it needs an x minus 3. And then they all would have the same combination in the denominator. So in order to make the first fraction have the same denominator as the last fraction, I have to take this and I have to multiply by x plus 3. So I got to do that on top. Then for the second fraction, I have x plus 3, so I have to multiply by x minus 3 in the numerator and denominator. So now my denominators are all the same. So I have to go through and multiply this all out. And when I do that, I have to distribute here and distribute here. So I get x squared plus 3x over my denominator. And then I have plus 2x squared minus 6x over my denominator. And that's going to be equal to, I didn't change anything about the last one, 18 over x plus 3, x minus 3. All right, my denominators are all the same, so I can get rid of those and I can solve the top. All right, so if I solve the top, I have x squared plus 3x plus 2x squared minus 6x equals 18. All right, so on the left side, I'm going to see, can anything go together? Well, I have 2x squareds, so those can go together. So 1x squared plus 2x squared gives me 3x squared. Then I have 3x and negative 6x. Those can go together, and that gives me negative 3x equals 18. All right, well, I have an x squared, so I got to move everything to one side. And that gives me 3x squared minus 3x minus 18 equals 0. Now I have to factor that. Obviously, right now, I have a lead coefficient of 3, and I can factor with a lead coefficient. That's totally fine. However, there is a greatest common factor. So remember, if we have a lead coefficient, we want to see, can we take it out? And all of these are divisible by 3. So yeah, I can take out a 3. So I'm going to bring this up here. And if I take out a 3, I'm left with x squared minus x minus 6. Much easier to factor. So always check for that. And then from here, I just want to factor the inside. And I want to add to -1, multiply to -6. So not 6 and 1, but 3 and 2. And which one has to be positive? Well, the 2, because the 3 has to be negative because there's more negatives. So what are my solutions after all of this? Well, they are 3 and -2. What do I have to do? I always have to check for extraneous solutions. And I didn't do my domain restriction at the beginning, so I need to go back and do that now. So my domain restriction, if I go and look, is looking at the denominator. X cannot be, they're all the same at x plus 3, x minus 3, so -3 or +3. That's my domain restriction. Whoop. So if x can't be 3 or -3, well, this is an extraneous solution because it can't be 3, and that is 3. So that means 2 is my only solution. All right, so I know that was a long one, but I think that's the longest we got. That really puts everything together here. And our last example, very similar to the one that we just did. So I'm going to ask that you pause the video, give this last one a try, and then play the video to check your solutions. If you can do this, you're really good to go. And then when you get to your 5.5 worksheet, you should be able to do all the problems on there because you've gone through this process, you've checked it, and you know you're on the right track. So pause the video and give this one a try. So another long one, but when you factor, you get x minus 4, x minus 3. So your domain restriction is x can't be 4 and x can't be 3. Otherwise, that makes the denominator undefined, and we have extraneous solutions. So we got to multiply the first one by x minus 3, the second one by x minus 4. So when you multiply those directly below that, I multiplied it out. Our denominators are the same, so we can cancel that. Just solve the numerator. Big thing here. It was subtraction. So if I'm subtracting 4x minus 16, I'm really adding -4x plus 16. I got to distribute that negative. And when you get down to the factoring and if it doesn't work, that's maybe where you made the mistake. So then I write it all out, combine like terms, get everything to one side, factor. Could factor with a lead coefficient, but I always want to check to see if it's a GCF, which it is. And when I take out that, I'm factoring x squared minus 5x plus 6 to get x minus 3, x minus 2, and solutions of 3 and 2. Check for extraneous. 3 is extraneous, so that's not a solution, but 2 is. So 2 is the solution to this rational equation. All right, so now take all of this and go ahead and complete part 2 and the back side of your 5.5 worksheet for the next class.